Basics of expressions. Navigating in the function editor. Okay, so we have open the Tahoma 2D screen. We go to the timing. Under timing, you're going to see by default, well, in my experience, it's generally varied, but typically it's crowded here in the rows and columns view. If you're not seeing the rows and columns view, you click this icon in the upper right-hand corner. That swaps between the curves view, the function curve editor, and the regular rows and columns view. When it's crowded like this, it makes it tricky to navigate. What you can do is go over and click on the top level icon until it turns black and white, as essentially turning off the display of those values. When they show up in orange or some other color, click on that folder, turn everything black and white. Makes everything easier to only show what you're interested in seeing. Next thing we can do is right-click and say, Show Animated Only. Now that's going to also restrict the values that we can click through, the attributes. If you ever need to show them again, you can just right-click and choose Show All. And then you'll see all the attributes only from that context. So this makes it handy. You can essentially turn everything off at the top level, and then you can navigate down to the object you're interested in getting the details for, and then turn the Show All back on at that level. Now we're going to take a look at this moment at the box mesh. This happens to be a detail. I have a box. I have a plastic tool mesh applied to it. We're going to get to that in a future video. For the purpose of this video, I just wanted to show the navigation, so that's what we're going to focus on. One of the things that I have animated is the position along the path. Now, position along the path is set to ease in, ease out. That's your typical form of interpolation. You can see it on the curve. It's easy to adjust this way. And what we're going to focus on is expressions. I have the rotation set with an expression. Notice what I'll do is click on the headings of these columns. You can click on individual frames, but what I've been doing, and what I suggest you do as you learn about expressions, is deal with everything at the full exposure level. Don't be going to the frame level just yet, because it's too easy to get confused about whether you're looking at an expression value or you're looking at something that was set using the traditional interpolation way of setting a keyframe manually and those sorts of things. One of the things that I find challenging in working with expressions is there's some detail there. You really have to be focused. You can't be trying to multitask, especially while you're trying to learn about expressions. So deal with things at the full column level by clicking on the headers. And you'll notice one thing you can do is when you click on a header like that, you can hit the delete key, and it's going to wipe out all the interpolations that have been set for that particular attribute, in this case, rotation. I'm hitting Control-Z to bring back what I had. Notice as I scroll down, I have a frame range set here, exposed frames all the way up to 101, but I'm only actively using the ones up to 99. So as I scroll down, you can see I got values all the way up to 101. If I were to select at the header level, it's selecting all the frames that I have exposed. It's not just worrying about the ones that are in the active play position, but it's worrying about all the, it's going to take all the frames that are exposed. I should point out the way I got here, different from having a traditional type of interpolation selected that you might be familiar with. If you click the expression as the type of interpolation, that's how you get to where I am right now. And you're able to enter a function, a formula, a reference to other objects. We happen to be sitting on column 3. That's the column. I've given it a title of box mesh for readability purposes on the X sheet or the timeline. But the value that is most often used in expressions, and this is somewhat of a limitation, is the column number. You may call it box mesh, but you can't refer to it as box mesh within your formulas. You have to refer to it as column 3. So it's important to be familiar with all 3 areas of this function editor that we're looking at right now. We have the hierarchy here, navigation hierarchy. We've got the rows and columns where the values will be shown. And we've got the box where we're selecting the interpolation and putting in the expression. In this case, it happens to be a function called random, and it's spelled RND. And I'm saying I want a random number with a value between -5 and +5. And you can see it goes down to the fractional level. You can add additional functions, wrap this in an additional function if you want to have your outcome be an integer specifically. But in this case, it's fine that we've got integer decimal values. And the unit, it's going to specify the unit down here. And that's a tiny little circle that it's showing in there, but it's the degree symbol. So it's showing you that the value that it's giving you is in degrees, because rotation as a field deals with degrees. Notice box mesh. Now this is another thing to be aware of. Up on the top, just like with the animate tool, which we currently have active, you're able to pick rotation, and there we go. So as I click through the values here in the rows and columns, you'll notice that it updates here on the animate tool options. So these are useful things to be aware of, that they're tied together that way. Not everything always is. You can make selections within one viewer, and it won't necessarily link in the other viewer that you're looking at. So again, this is why you have to be focused. You have to have your quiet time when you're trying to learn expressions, because it can get frustrating very quickly, very fast, and things can just get all confusing and you feel like you've hit a dead end. My advice, start over. Go back to your last good save, come back at it with a fresh set of eyes, and go carefully through it. It'll get better. As you learn more about it, as you get more familiar, you'll just have that intuition. You'll know where to look. You'll know where the problems might come from. And that's where the examples that I'm going to present in future videos are going to help you. You're going to have a working example that you know works, and you'll be able to pick through it and find why it works and why yours doesn't, and go forward from there. Okay, let's take a look now at the manual. In the manual, you want to look for the section called Using Interpolations Based on Expressions. That's going to give you all the description that's available to you in the documentation, and you can read through this. I'm not going to fully cover it here, but it's indicating to you that as you're working with those expressions in that box within the software, color coding is used to indicate whether something is a variable, a function, constant. Most important thing to look for is when there's a syntax error, it's going to show up in red. That means that the expression you're typing in right now, there's something it doesn't like about it. If one of these values, for example, in the screenshot that I'm showing, if one of those was red, you would have to fix that. If you click apply and you try to apply that, it's not going to give you another error message. It's not going to give you a pop-up or anything. It's basically just going to ignore it. It's not going to change the values that are in the rows and columns view. It's going to ignore what you tried to do. So that's how that works. Now, we're looking at operators that are possible. Now, what this all is very similar to is if you've ever used a spreadsheet software like LibreOffice Calc or Microsoft Excel, it's a lot similar to how it works in there. You're putting in formulas to derive a result for that cell based on other cells coming from, values from other objects, from functions. And so if you're familiar with how to put in a formula in a spreadsheet, this expressions is going to be very familiar to you as well. You can read through these functions and then you can test them out. And I suggest when testing a formula, when you want to see how something works, a good way to do that is, well, as you see right here, rotation. Now that's looking for a degree value. If I wanted something that was looking for a numeric value, like X or Y, a position on the picture plane, then I could pick the X value and I could say, I want to create an expression. And then I can put an expression in here that's going to return to me a value, and I would see that value show up in the column. And that's a way to test if you have an understanding of the formula or not. If you're not sure what the value is that you're going to be getting, just pick an empty column and put in your formula and look to see what the results are. I suggest this when you're working on a complex formula that's going to, let's say, pull from two different other values and do a type of multiplication on them, or you do something, a function like sine or cosine, and you're not sure where it's going wrong, then split it apart. Work on that innermost part first and confirm the values, and then start adding to the complexity of it. I also suggest that you open up something like Notepad so that you're able to take the expression, paste it somewhere, so you have that copy to go back to as you work and make modifications. And it's also possible that you have stored some of these formulas in a note-taking software like OneNote or Evernote, one of those, or saved it as a text file somewhere, so that you can bring up these examples and copy and paste and then make changes to them to get them to fit your exact situation, so that you're referring to column 3 and you're referring to the X value instead of the Y value. Maybe the formula you saved refers to the Y value, but now you want to use it for the X value. So I suggest that. I suggest keeping a notepad off to the side, putting your formulas out there, saving them, and reusing them that way as well. And one of the things you'll see in the future examples that I go through is converting from one value type to another. In this case, you can see the X value is in pixels. That's the unit. And as we saw before, the rotation, that's in degrees. Well, sometimes you need to run a formula to convert, in this case, from an angle to a distance measurement, sine, cosine, one of the trigonometry functions. And that's one way that you can get a X value from a degree value. Other times you may be just converting, let's say the range is it's still a number, but it's ranging from 0 to 1 because it's talking about the position along a path. And you're interested in, let's say, you want to break that down into an integer value of 10 segments along that path from 0 to 100, but you're interested in 1 through 10. So you create a little formula that divides the value for the path position by 10, so that your result is going to be a number from 1 through 10. You'll do something with rounding or addition plus rounding, anything you need to do in order to convert from a 0 to 100 value into a 1 to 10 value. Those are some of the things you'll be dealing with. Now, this video that I'm presenting as a basics of expressions, I believe that you'll be able to get some value if you come back to this video as you work through the examples later. Use this particular video as a reference. I don't expect that everything's going to be clear with me just talking and showing some simple screens. It's going to become clear when you repeat the examples yourself, when you're actually trying to use the software. But I'm trying to collect all in one place key points that are valid throughout the examples that will follow and throughout your time creating expressions. So treat this particular video as sort of a guide looking forward toward those future demos and as a reference to come back to as you learn more to check your level of understanding something with what I was thinking at the time I recorded this video. As an example of that type of reference information, what I'm showing on screen right now is a list of definitions that I put together because I found it confusing reading through the documentation what some of the terms meant. I came to understand better as I started to work through and create some examples. So I'm going to just share my current thoughts on what these mean, and you can compare that to your own interpretation as you read the manual or as you work through the examples later. The term delta. It says the difference between the target frame and the current one. And what they're talking about when they say difference is my current position within the timeline, or I'll say timeline because it's really what it is, whether you're talking about X-sheet view or timeline view, you're talking about where you are on the frames. F refers to a frame in the timeline, starting from the beginning of the timeline all the way to the end. And 2 frames prior to the current, when you say F minus 2, that means my current frame minus 2. So I want to look at the position 2 frames prior to where I currently am. And I'm calling that the global frame numbers because it's regardless of the particular interpolation or the period, it's one of the other words that they use. That's the time between one key and another key, referring to that as a period of interpolation. Okay, so that's now getting us into what R means. 2 frames after the current. In this case, I'm saying R plus 2. So that means 2 frames after the current frame using a frame number which is relative to the current transition. So when you set up a keyframe, that starts the count over again, basically. You're saying first frame in this transition, second frame in this transition, third frame in this transition. Instead of starting all the way at the beginning of your animation, you're referring to the current transition. T minus 10. That's 10% prior to the current frame, based on a relative distance along a transition, similar to how a motion path uses percentage values. So you can have a motion path very short, but still it's going to start at 0% and stop at 100%. If you stretch that motion path out, doesn't matter how long you stretch it, it's still going to go from 0 to 100 because it's referring to a percentage along that path. Now, this is a similar concept. Using T to refer to the delta is saying what percentage ahead of where I am or after where I am based on the current transition section of time referred to between the 2 keyframes. Okay, that's my current understanding. Might change in the future, but I just wanted to give you that to maybe help get you started as well. POS, pause, position along a motion path. This value is a percent with a range from 0 to 100%. Sometimes it's also referred to as path. That's the variable that you'll see within the expressions. Period. A span of frames on the timeline of the specified number of frames. So in their expressions, they use the word period to mean when you specify a number like 10 or 20, that means every 20 frames you want this function to be active. And so the period is the number of frames that this thing is going to be active, if it's a one-time function, or if it's going to recur, if it's going to be repeating. So transition is the interpolation between keys. So the two are kind of similar, but you'll develop your own understanding through use as you get more experience using expressions. This is just my current working understanding. I would phrase it that way. Okay, now I'm just going to throw a bunch of tips at you, and this is the key part of the video which I think could prove useful to revisit in the future. If nothing else, as a reminder, these are things that I considered important, And you can make your own decision after you start going through some of the other videos if you want to incorporate any of these things into your workflow or have as a reminder. Save early, save often. Control S after every crucial step you do that you do not want to redo. That's going to be very important with working with expressions, because things might not go the way you want them to. You may corrupt some of the things you've set up, and you may want to back out those changes. I'm just saying that also there are times where the application can crash on you. So if you've gone through and you've worked on an expression for 20 minutes, you don't want the application to crash before you've saved the good part of what you've done. So save early, save often. Press Control S. Spam that key sequence often. Use the spreadsheet view to see the result value from formulas. That's essentially the way that you're able to see how the expression is performing. When you're able to see the values there, you'll know if you're getting reasonable values for what you're trying to do or not. And if you're looking at the graph view, you kind of see a visual representation. Maybe over time that's more meaningful to you, but I find the spreadsheet view, the rows and columns view, to be more informative. On a similar note, and I already covered that earlier in this video, you want to use an available value column to test a formula. It can be a good way to experiment with a function to learn how it works. So sometimes I use the stacking order column because I very infrequently use that one. And you just want to put in your expressions. Maybe you've got a complex expression in another column that you're working on, and you just want to do a quick breakout to test a portion of that expression. Go into the stacking order column, test it out in there. Once you work out the details, bring it back to your complex formula. And be sure to click the column heading and hit delete after you're done doing that experimentation, just so you don't have any side effects later on from values being in that column. And that leads to my next comment. Break a complex formula into parts and test the parts. That's an example how to do that. Another example is to take that entire complex formula and put it into a notepad or something so that you're able to split it apart at the same time you're seeing the full formula. And then you can bring pieces back into Tahoma, test them out, and then build up your complex formula that way. Copy and paste formulas. Oh, when you want to copy a formula, an expression formula, you'll have to right-click on it. The copy and paste doesn't work. So let me take a quick look at that. You see if I'm sitting here on, I've got it highlighted. If I hit Control C and I try to do a Control V, it has not been working for me. So instead, you have to click on Copy. Same for later on when you're trying to pick up a reference. See, I'm on column 3, and I'm looking at the rotation value. I'm able to double-click here and choose this as a label, and then I have to right-click and choose Copy. Control-C won't work there. So pressing Control-C, that's an old habit. You'll know if you run into a situation where it's not working for you when you go to paste and the value's not there. Don't go doing any extensive troubleshooting. Just come back and right-click and choose Copy. Control-C just didn't work for you in that case. I've already covered this comment a couple of times. Keep an open text editor nearby to copy and paste formulas. As you build up formulas, keep a library of example formulas to refer to or to copy and paste and modify. I've mentioned that a couple times as well. Expressions, like any other interpolation, have an active frame range. That's something that you'll notice here. It says from frame 1 to frame 101. This expression is active. So even without scrolling through the rows and columns to get to that last frame, you can tell here that this is the frame range where it's active. So when I made the comments earlier about working with things at the full column level, you'll notice this will give you that full range. and I'm just saying that for clarity, in the future, you'll be able to mix things. You'll be able to have part of the interpolation for your animation be the traditional way, and part of it be an expression. And it's possible to do that. Click the column header to create a formula that spans the current active frame range. I've covered that several times. Click the column header and press delete to remove any current keys before entering a formula that you want to cover the full active frame range. I've also covered that a few times. That's my suggestion, that you work that way until you get more familiar with expressions, because it makes it easier to troubleshoot. If you've only, and I was doing this early on when I was experimenting, I was only covering part of my animation with the expressions because I might have had a frame selected, I might have had a short section of frame selected, and then when I was making my changes over here, it was setting those as the from and the to value. So I'd play back the animation and I'd wonder why things were going not the way I intended. And it's because I was mixing so many different ranges within that one column. I suggest you avoid that while you're learning. Okay, expressions can refer to the results of other expressions. So what that's suggesting is that when you have an expression on one attribute of an object, it produces a value. Now that value can feed into another expression on another attribute. So part of the value of that is that you can keep two objects in sync. You can have one actually generate the value and the other one just refer to it and say, I like what that object is doing. I want to do the same thing. Let me just point to it. So that's a powerful thing. That's a way to synchronize multiple objects so they all stay in sync, and all you have to worry about is changing the values on the original object that everyone else is pointing to. Expressions can refer to values from other frames before and after the current frame. That's something that you'll see demonstrated when we get into the wave expressions and the one with the tail wagging. What they're essentially doing is saying, I want my value to be the same as the earlier segment of this link, and just what that segment had for the prior frame, I want that to be my current frame. So it's just another step beyond. Not only am I pointing to an expression from a different object, but I'm pointing to it from a different point along the timeline. Copy the current object reference string from the function editor. It's easier than retyping the string. So this is what I was showing before. Every time you select an object, it's going to, if you pick the column, it's going to show you here the reference for that. So if you're going to create an expression and you want to refer to the shear horizontal value for column 3, it's giving you right there, the string that you want to use. Now this I know explicitly is one that doesn't work with the Control-C. You have to definitely right-click and choose copy on this one. As a matter of fact, it's showing us right here that there's no shortcut set for it. Maybe something that we can fix ourselves later on, going through the shortcut setup, but it's your reminder right here. The fact that it doesn't say Control-C here, that's your indicator that Control-C is not going to work here. I'm learning even as I'm recording this video. It's a good thing. Use a constant value in an expression to lock the column to that value. This prevents accidental changes to that column. So that's a detail that can be helpful. If, for example, you are later on in your learning and you're trying to set up something that's constrained so it can only move along the x-axis and not along the y-axis. Well, how you do that is you pick the y-axis and you create an expression. And what do you want? Are you going to put in a complex formula? Nope, you're just going to type 0 and apply. You have just locked the y-axis to the value of 0. You can't accidentally change it now. I'm clicking through here. I type in 7. It's ignoring me. I type in 10. Again, it ignores me because I've locked the value at 0 by putting in an expression covering the entire range. Well, you see what it did just there because I typed in a value. Let me delete that now. Anytime you see a key set along the range where you're trying to have a full expression, just go ahead and delete that one cell and let it go back to the full range. But what I've done by putting in an expression with a constant value, it's basically locked that column now. It's a good thing to avoid accidentally changing something. Maybe you're going over to the graph mode. You don't want to accidentally change the y value. That's how you lock it. Set expressions up to pull their values from a single source expression or value. In this way, changes in that one place, the source, will propagate automatically. And that's something I was mentioning before, that you can have a reference to an expression in another object. So what that means is, let's say I have two objects and I want them to stay coordinated. So when I move one along the x-axis, I want to move the other along the x-axis too. In my x-axis, I can put an expression, and in that expression, I can refer to, let's say there was a column 5, and I wanted to coordinate with that. I would point to column 5's x value. Now, my x column is going to be pulling all of its values from that column 5 object. That's what this is referring to. So then if I change the values on column 5, column 3 is going to follow along, and it's going to make things easier. You don't have to set the values in multiple places from that point forward. Okay, that covers the tips that I wanted to cover, and I believe that wraps up this section on the basics of expressions. So future videos are going to cover now the details. And thank you for following along on this journey.